Every system ever built has a perimeter. Some have walls, some are virtual, and some live in the human mind. Okay. Every perimeter has a purpose to keep safe what lies within. For a system, that might be data or code. For a nation, natural resources or people. For a mind, peace or sanity. Every gate needs a guard. Some stand watch with guns, others with bored eyes at a keyboard. Some only ask, who goes there? Others don't ask, they just shoot first. No matter the gate, a guard's job is lonely. As hours pass with nothing to report, then suddenly there's a crisis. The guard's whole world shrinks to that moment. If they blink, if they hesitate, if they get one thing wrong, all bets are off. Okay? They might never get their world back. I am here today to talk about one such gate, the outermost gate of the empire, the place where code meets the internet, where messages arrive unfiltered and raw. They come from everywhere, millions per second, bearing every possible flag and payload, and most of them we ignore. They are rumors. They might contain news, but until we check their pedigree, they are useless, maybe dangerous. They can spread confusion, chaos, and harm. At this gate, the difference between rumor and news is a matter of life and death. This is a story about how we solved that problem at scale. How do we build a system where every message that passes through the gate does so with perfect provenance? First, we wrote down the law. We call it signed or silent. Messages passing this gate must be signed or silent. Let's unpack that. Messages arriving at the gate are like hailers from distant worlds. Most are harmless, but some bring trouble. To sort them, we check if the sender is recognized and if the message matches what we expect. If both are true, we can trust the message. We let it pass, no questions asked. This is a green light, literally. Our team lead coded a literal green checkmark that shows up in our logs when this happens. It's our version of kaboom, except in this case, it means all clear. What about messages from unknown senders or those that don't match expectations? These are yellow lights. They need more scrutiny. We open them up, study them, and decide what to do next. Maybe we've seen this message before. In that case, we delete it and log it as a dupe. Or maybe it looks interesting. In that case, we pin it for follow-up. Or maybe it's just noise. In that case, we throw it away and log it as dropped. What about messages that don't arrive in the expected format or that arrive too often? We drop them and log them as rejected. All these decisions are logged in human-friendly ways, so the night shift or the new hire can understand what happened. So far, we've covered messages that are either good or bad. What about messages that could go either way? These are the red lights. We call them ambiguous. Unlike other messages, we do not automatically drop them. Instead, we present them to an engineer on call. It's their responsibility to decide what to do next. Maybe the message needs further verification. Maybe it should be blocked. Maybe it's just a false alarm. Only an actual human can decide. To help engineers make the right call, we give them all the context we can muster. What's the source of the message? Have we seen it before? Is the sender known to be trustworthy? Is it acting suspiciously? Has anyone else seen anything strange lately? By providing this level of detail, we empower engineers to triage thousands of alerts without getting overwhelmed. Every decision made at the gate, whether green, yellow, or red, is logged in a canonical form, so humans can always see what happened and why. We believe this level of transparency is essential to maintaining trust in our systems. We've been using this system for a while now, and it works great. We catch bad messages, and we don't get bogged down by false alarms. It takes less than a second from alert to resolution, and engineers love it. They have the context they need to make the right call without having to dig through logs or chase down colleagues. If you're thinking of building something similar, we've open sourced everything we've talked about today under the Eclipse Guard Playbooks project. you'll find HMAC rights, reject paths, and checklists that will help you implement signed or silent in your own systems. Today, we talked about a lot of different messages passing through a single gate. In reality, there are many gates, each protecting valuable things. Some protect code, others protect data, and still others protect human minds. The goal of signed or silent is to help you staff and secure any gate where the difference between rumor and news is a matter of life and death. It doesn't matter if you're talking about code or people or anything in between. The problems are universal, and so are the solutions. No matter the gate, a guard's job is lonely, but it doesn't have to be. With the right tools, every gate can be staffed and secured, no matter how many messages come through. And that's it for today. I'm the distinguished engineer for a major tech company. Remember, in the code we ship, security is everyone's job. Let's keep shipping and stay safe.